Just a second. Okay, so now any system will say any system any system which will which exhibits the linear constant coefficient. Second order differential equation of the form second order differential equation of the form what is that form? D square C dt square plus A dC by dt plus B C of t B R of t. That is one. Okay. So any system which will be having a linear differential equation of this form is will be called as second order system. So is called second order system. Okay. A and B are real constants. A and B, they are real constants. Okay. These two are real constants. Now, before we will formalize this system, let's talk about some definitions. Let's talk about some definitions of this system. So, first definition which we will be talking about is a natural frequency. Omega n. Okay. A natural frequency is what? Natural frequency of a second order system, it is a frequency of oscillations of the system, but that will be without damping. So this is frequency of oscillations of a system without damping. Underground undamped system is the best example. Frequency of oscillation of the system without damping. There will be no damping. That's whatever the natural frequency is there, that will be called as whatever the frequency we're getting naturally, that will be called as natural frequency. For example, frequency of oscillations of frequency of oscillations of RLC circuit with resistance short circuited. With resistance shorted will be natural frequency. will be the natural frequency. So that's the natural frequency. There should be no damping. That whatever the oscillations we are getting from the system, that oscillations, and but we should not damp those oscillations. And those is that's called the natural frequency. Next is second definition is damping ratio. So damping ratio is what? We define the damping ratio, we will denote by damping ratio is denoted by Z. So what is the definition of xi? This is called xi, a Greek word xi. Greek word is xi. This is called, we define this xi as, xi is defined as ratio of exponential decay frequency divided by natural frequency. Divided by natural frequency. Natural frequency will be in radians per second. What is basically, if we take the reciprocal of, we can write it 1 by 2 natural period, that will be in terms of seconds, divided by exponential time constant. So what is this basically? We are talking about xi. Xi is basically a ratio of exponential decay frequency. We have seen exponential decay frequency. Exponential decay will real part will be responsible, whereas the frequency of oscillations, if we are talking about, then imaginary part will be involved. We have last time seen it. So the definition for this quantity is one that compares the exponential decay frequency of any system or envelope to the natural frequency, and that frequency will remain constant. There will be no change in that frequency regardless of whatever the response scale will be, whatever the response we'll get. So that is going to remain constant. Also, if we talk about the reciprocal, which is proportional to, we have seen the natural ratio of natural period to the exponential time, that will also remain constant regardless of the time base. So I'm repeating again, this definition, this compares what? It's the one that compares the exponential decay frequency of the envelope to the natural frequency. So there is a comparison, compares this exponential decay frequency of the envelope or a system to what? To the natural frequency. Okay, this is the what xi means. So it's a ratio of exponential decay frequency divided by natural frequency. Now taking the Laplace, okay, taking the Laplace transform of equation number 1. What we are going to get? So we have first d square by dt c. So d square by dt will be changed to s square c of s plus, then we have a dc by dt. So a will remain as it is, d by dt will be s, then that will be again c of s in what? In s domain. Then we have b c of s. That will be equal to b r of s. You can have a look here. This should have been c of t here, sorry, in time domains. dc of t, bc of t, and then this, we have changed this to Laplace transform. So from out of this, you can see we can take C of S common, then C of S by R of S we can write C of S divided by R of S can be written as B divided by S square plus AS plus B. So this is what earlier we have considered also. The same thing we are trying to get. The four options we have got out of this, the same we have got here also. Now, let us first consider when a constant A is 0. When constant A, which is in the denominator, is equal to 0, then what is going to happen? If this is 0, this will become b square s square plus b square. So roots of this will be purely imaginary. When roots are purely imaginary, that will be undamped system. It's very clear. Roots are purely imaginary, so there is no this part. We have seen it last time. A is equivalent to 0. The system will be undamped. So here we can write system will be undamped. There is only natural frequency of oscillations will be there, and there will be no damping, as we have seen in case number 2. And second, with this poles after transfer function, poles of transfer function, that is C of S by R of S, will happen to what? They will lie on the, they would be on the they would be on JW axis. That means on the imaginary axis, okay, of S plane. In other words, if you have to use simple words, then we can say the poles of the transfer function would be purely imaginary. The poles of the transfer function would be purely imaginary. It is very clear. Poles of the transfer function are going to be purely imaginary. Okay. Now what's happening? if poles of transfer function are purely imaginary, then A is equivalent to 0. This is the undamped system. There is no damping in the system. Whatever the frequencies we are getting, that will be the natural frequency. So by definition, what will natural frequency means? Natural frequency means that is the frequency of the oscillation of the system without damping. So let us say here, we say omega n be the frequency of the oscillations of the, let it be the natural frequency which is the frequency of the oscillations of the system. This is frequency of the oscillations of the system. So it is without damping. Nothing has been done to. So we call this as the natural frequency. When we call this as the natural frequency, so what is going to happen? That S is going to become under root of plus minus under root of B. The poles of the system with A equal to 0 are on j omega axis at, so we can get two poles, that is if S1 of 2 is plus minus under root of B. We know that A we have substituted the value A equal to 0. So that means what? Then whatever the frequency of oscillations we are getting, because this is on the imaginary axis, this is on the, this should be included JB. Okay, because this will be s square will be equal to minus b, then s will be 1, 2 roots will be there, plus minus under root of minus b, it will be minus plus minus uh, under root of b, j we can take. So what is this b now? This is frequency of oscillations without damping. So that means that's a natural frequency. It is frequency of the oscillations of this system without damping. So we can say here omega n will be equal to under root b. This is very important point. Tanzib, is it clear or not?
Yes, sir. Clear.
Okay, so we have what taken, A is equal to 0, system is undamped, there is no damping in the system. Whatever the frequency we are getting in the system is a natural frequency. So frequency oscillations of the system is a natural frequency. So that is equal to what? That is equal to under root B radians per second. That is equal to under root B radians per second. Next is, if we square it, then B will become omega n square. Omega n is under root b. So if we square it, b will become omega n square. Now next our aim is to find the value of a. Now let us say if the complex poles of the transfer function are on the left side of S plane. Let us say next is to find the value of a. Next we have to find the value of a. And let us say if the complex poles of the transfer function C of s divided by r of s lie to the left of S plane. Lie to the left of S plane. Then system is said to be what? Then what is the system we have? We have a system called underdamped system, whose roots are complex and imaginary, purely imaginary, but they are conjugate to each other. So this is an underdamped system. Now let us assume a system is underdamped now. The complex pole will have a real part. If system is underdamped, let's assume this. Let us assume this system is underdamped. Then what is happening here? This is s square plus as plus b. So this will be equal to s will be equal to 1 2 roots minus b plus minus under root of b square minus 4a and c divided by 2a minus b. Yeah, 2a is 1. A square here will be 1 square. Sorry. Just a second. Yeah. Okay. So this is b square minus a minus b plus minus under root of b square. Fine. B square minus 4a. 4a is 1. C is b multiplied by 2a. That is 2 into 1. So here you can see if your system is a underdamped system, then a square minus 4ab divided by 2. So you can see in underdamped system, we have seen last time that real part is responsible for what? Real part is responsible for the exponential decay. Real part is responsible for the exponential decay. So complex pole will have a real part. Let us say that real part is on the sigma. I have told you in the S-plane we have sigma here and we have imaginary axis. This is S-plane. So sigma will be equal to minus a by 2, real part. This is other is the imaginary part. This will be responsible for the exponential decay. Second next will be responsible for the frequency of oscillations. Minus a by 2. This is evident from, we can see from the roots of this one. The magnitude of two values is then exponential. This magnitude is nothing but the magnitude of two values, that is a and b, is nothing but the exponential decay frequency. So xi we have defined, sorry, the magnitude of this value, I will write for your information, is then the exponential decay frequency. So xi we have defined earlier, exponential decay frequency. I am writing it again. Exponential decay frequency divided by what? Natural frequency. Radians per second. Okay. So xi will be modulus of sigma divided, modulus of sigma divided by omega n. That will be modulus it will become a by 2 omega n. We are taking the positive modulus, that's why minus was there, but we are taking modulus of this one. Now let's substitute this value, substituting the value of b and substituting the value of xi in what? In equation number 2 here. Okay, substituting this value in equation number 2. So substituting the value of a and b, sorry, not a, b and, what was the value of, yeah, a and b we can write, we don't have xi here, a and b in equation 2. So what is equation 2? B value we can substitute. B value is what? B value is omega n square. A value we can get it from here. See? A. So here we can get A value. A value will be 2 xi omega n. So now substitute this value. After substituting this value, transfer function g of s, which should be equal to c of s by r of s, will be equal to b value is omega n square divided by s square. A value is 2 xi omega ns, s plus omega n square. So this is equation number 3, is a prototype second order system. What is a prototype? It's a original as pattern. Sometimes we make a copy, we have to do some experiment, write some, we make simulators of just prototypes, because they are not actual, because we build those simulators with some assumptions that this will be 0 or so on and so forth will be this assumptions. It's not an actual system. It's not an 100% actual system, but it resembles the actual system. That's why we call it a prototype. Thus, our prototype second order transfer function second order transfer function looks as given in equation 3. Okay. Our next task will be to represent this transfer function in block diagram. So we can write this C of S by R of S in terms of what? Our aim is to write it in terms of G of S transfer function plus 1 plus G of S H of S. Like this we have to represent it. So what we can do, we can take the denominator common, omega n square is numerator. We are not going to do anything with the numerator. Okay, so this is okay. Okay, so this is what we are. We have got s square in the denominator common, and we have okay. We have written like that. Then we have taken common. This will be 1. Then this will be divided by this. Okay. Okay. So next, what we have now, let us call it equation number 4th. You compare 4th with equation 4th with G of S is equal to, or sorry, yeah, output by input will write CFS by RFS is equal to G of S one plus G of S. Let us compare this 4 equation. We can draw the block diagram. Let's draw the block diagram. Just we have seen it. This is input, this is output. Okay. This is the transfer function G of S, which was equal to omega n square S into S plus 2 xi omega n omega, sorry, 2 xi omega n, and in feedback we will have 1. So that's what we have written here. See, this is the transfer function. You can write it like this form, this divided by 1 plus G of S H of S. That's what form we have written it. So we can represent, this is the way to represent. So this is what? This is block diagram of a general second order system. Okay, so this is the block diagram of general second order system. I hope this is clear. Roll number 6.
Yes, sir.
Any doubts? So we have to represent this. We have to first derive it, and we have to derive it from this, considering two things: b value and a value. B value we can get from assuming the system as undamped system, and then we can get the free b as the frequency of natural frequency of oscillations of the system. And second, we have to get the value of xi, that is exponential decay frequency, and that's natural frequency. From that we'll get the value of psi. A value we'll get, a and b will substitute, and we are going to get this second order. You have to memorize the second order system is like this: omega n square s square plus 2 xi omega n s plus this. Next we have a small question. Given the transfer function is like this, and you need to find xi and omega n. These two values you have to find, xi and omega n. Okay, now given we have transfer function like this, so let's call it equation number 1. We can write g of s is equal to 6 square s square plus 4.2 s plus 6 square. So comparing this equation with general second order system. So we have g of s is equal to omega n square s square plus 2 xi omega ns plus omega n square. This is the second order system. So we have to compare first and two equations. Now by comparing, we can see omega n square is equal to 6 square. So which means omega n is plus 6 radians per second. So omega n we have got. Now we know 2 xi omega n is equal to 4.2, and out of this xi will be equal to 4.2 divided by 2 into omega n, that is 6, 12. So that will come out to be xi is 0.35. Oh, before this, actually I have to take one more thing. Anyway, we do this numerical, later we'll. Xi is 0.36. Okay, so this is the value of, you have to find only now. Okay, this was small numerical, why you have to find the xi and omega n, but later we have to interpret also. So that was a numerical, we have got the values. So let's say we summarize. Now we have defined the values of xi and omega n. We have already defined that. Let us relate these quantities with the quantities to the pole location. If we solve for the poles, so we can find S1 of 2. If we solve for the poles, we will get xi omega n plus minus omega n under root of xi square minus 1. So this is the, if we solve this equation for the poles, s square plus 2 xi omega ns plus minus b will be minus 2 xi omega ns plus minus b square minus b plus minus b square, that is 4 xi square omega n square under root of minus b square minus 4ac, that is 4 1 into omega n square, and we'll get the roots like this. If we are solving this equation for the roots, for the poles in the denominator, we'll get it like this. So let us summarize all the cases in the table where we can have different options of xi. So let me summarize the. summarizing all cases in the tabular form. Values of xi and the responses we'll see. So let us make a table here. Okay, first will be range of xi, and second will be types of closed loop poles. Third will be natural response, and fourth will be system classification. Okay. So number one will be range of xi. Second will be types of closed loop poles. Third will be nature of response. Fourth will be system classification, that means type of response. Okay, so number one is when xi is equal to 0. Xi is equal to 0, we have just now seen type of closed loop purely imaginary. Poles will be purely imaginary. Then if this is purely imaginary, then there will be oscillations that will be with constant frequency and amplitude. That means with natural frequency, oscillations with constant frequency and amplitude. But the type of response here will be undamped. There will be no damping in the system because roots are purely imaginary. So xi 0 means undamped. Next. Okay, this is another. Okay, next is if xi is less than 1. Xi is less than 1. So what will happen? That's an underdamped. We have seen complex conjugate with negative real part. Poles will be complex and they will be also conjugate of each other. We have also seen this. And we have seen with negative real part. Real part will be negative. And what are the types, nature of response? Nature of response will be damped oscillations will be there. Oscillations will be there, but that will be damped. Because we will have the real part that will be responsible for exponential decay and imaginary part that will be responsible for frequency of oscillation. So this system will be treated as underdamped system. Type of the response will be underdamped. Now next is xi will be equal to 1. Then we have real, equal, and negative roots. Okay, that will be critical, pure, exponential. What does that mean? So we have real, roots are all real, that are equal and that are negative. So Real part is negative. There is no imaginary part at all. So what should be the type of the response? We will have, that will be purely exponential. So there will be only exponential decay. There will be no frequency of oscillation because we don't have an imaginary part. So that is a critically damped. There's only damping, critically damped. There is no frequency of oscillations. So next is if that is greater than 1, xi is greater than 1. So we will have real, unequal, and negative. So types of closed loop pools are real, unequal, and negative. So roots we will be having. So that will be what? Purely exponential. Again, because we'll have unequal now roots. Earlier it was equal. Exponential decay will be there, but that will be also slow. Response will be also slow and sluggish. We call it sluggish. That means response is slow. That is an overdamped system. I hope with the given theory you have understood what should be the value of xi. If it is 0, then it is undamped, 1, underdamped, 1, equal to 1, less than 1, underdamped, equal to 1, critically damped, and greater than 1, overdamped. So you should also know sometimes in the gate examinations only, the nature will be given. You have to identify the xi, or you have to identify the response. That means system classification, what is undamped. Sometimes the pure only the type of the closed loops will be given. So you have to understand it. So if here the question would have been what will be the expected response for this transfer function? The expected response xi we are getting is less than 1, so this is clearly an underdamped system. Less than 1, underdamped. So if we have to write for the response type also, that will be underdamped response. Okay, next problem we have. For each of the system shown in the figure below, find the value of xi and report the kind of expected response. Actually, I'll draw the transfer function. Okay. So let's say this is input. This is given to us, transfer function. 12 divided by s square plus 8s plus 12. And then we have output. Okay. Excuse me. Okay, now what we have here in the solution, we know in general it is s square plus as plus b. And then it was general system, by we change it to second order system. And then we have got omega n square plus divided by, sorry, s square plus 2 xi omega ns plus omega n square. Now you compare those two systems. We can write this under root of, we can write g of s as under root of 12 whole square divided by s square plus 2 psi k24 into 8 xi, sorry, xi omega ns plus under root of 12 square. Now here omega n square is under root of 12 whole square. So that means omega n is under root of 12 radians per second. So natural frequency we have got. Now we have what is we will be having. This is here 2 xi omega s. 2 xi omega n, coefficient of s we are taking. So in our question, what we have, sorry, what I have written here is 8s. I am writing the actual system here. Sorry, this is okay. This is 8s. This is equal to 8. Coefficient of s is 8. Coefficient of in that is 2 xi omega ns. So omega xi we will obtain from here. That will be 8 divided by 2. Omega n is under root 12. So that will be 4. Okay. And if you calculate this value of will be 1.155. Tanzib,
Yes, sir.
send me the log right now. Now xi is here greater than 1. Roll number 8. What is that? Roll number 10 or 8?
Sir,
Roll
9.
number
9. 9.
What is the response?
Overdamped.
Overdamped. So it's very clear. So sometimes this question can be asked in any type of examination. You will be given the system and you have to tell us the response. Now next,
सर ओमेगा एन कैसे आएगा √12?
huh?
ओमेगा एन कैसे आएगा √12 सर?
ओमेगा n कैसे आएगा?
स्क्वायर है ना एन कोई सिर्फ?
तो वही कर रहे हैं ना हम. ओमेगा n का स्क्वायर है, अंडर रूट 12 का स्क्वायर. ओमेगा n स्क्वायर विल बी इक्वल अंडर रूट 12 स्क्वायर, दैट विल बी ओमेगा अंडर रूट 12.
अरे सर ओमेगा एन का स्क्वायर है या सिर्फ एन का ही स्क्वायर है?
ये ओमेगा n का स्क्वायर है. पहले आप देखो ना पीछे.
ओके सर, ये बस.
आई थिंक यू आर स्लीपिंग एंड देन यू आर आस्किंग क्वेश्चन. ये कोई क्वेश्चन पूछने वाला नहीं है. यू हैव टू अंडरस्टैंड फ्रॉम द बैक व्हाट वी आर डूइंग. कैन सी हियर we have derived the expression. You should understand this is what we have derived. Okay, next is I will give you 2 minutes. Give me the response of this one. Transfer function is 16 divided by s square plus 8s plus 16. चलिए जल्दी बताइए मुझे what should be omega n, what should be xi, and what is the type of response we have. जल्दी रुतबा 27. जल्दी जल्दी. रोल नंबर 5.
यस सर.
हाँ बताइए रेस्पॉन्स. रोल नंबर 51 पाकिजा. 51.
Yes, sir.
हाँ व्हाट इज द रेस्पॉन्स.
सर कर रही हूँ.
हाँ
सर कर रही हूँ.
टाइम नहीं है इतना. रोल नंबर 27 रुतबा. I think 50 is Rutba or 27. 20 Sharik.
Yes, sir.
What is the response?
I am doing it, sir, right now.
No time nahi hai. It's a very simple numerical. Use your calculator and find it. अब आपको डायरेक्टली आना चाहिए. ओमेगा n should be 4 radians per second.
सर 1 आ रहा है जाई।
तो क्या हुआ वो? क्रिटिकली डैम्प्ड। रिस्पॉन्स भी बोलो ना।
क्रिटिकली डैम्प्ड सर।
या तो xi will be equal to 1. This is critically damped. Next. इसका रेस्पॉन्स बताइए। g of s is s square plus 8s plus 20. ये जल्दी कीजिए आप सारे, आपको होमवर्क करने हैं। 400 divided by s square plus 12s plus 400. Then you have g of s is 900 divided by s square plus 90s plus 900. Then you have g of s is 225 divided by s square plus 30s plus 225. Okay. Then one more we have g of s is 625 divided by s square 625. ओएस रशीद अपना ऑडियो बंद करो। फैजान 12, रोल नंबर 12।
Yes, sir.
लास्ट
Yes,
का
sir.
बिना देखे रेस्पॉन्स बताओ। 625 डिवाइड बाय s square plus 625।
ओमेगा n है बराबर 25 के।
नहीं, बिना देखे रेस्पॉन्स बताओ। 25 स्क्वायर डिवाइड बाय s square plus 25 स्क्वायर। इसमें तो है ही नहीं, बीच वाला xi is equal to 0, तो क्या है ये?
सर अनडैम्प्ड है ना?
अनडैम्प्ड।
या अनडैम्प्ड सॉरी, डैम्प्ड है। इसमें सिर्फ ये है।
ओके, पहला वाला किसने किया है? फर्स्ट
मैं वो किया, उसको होता है अंडरडैम्प्ड, टी को होता है अंडरडैम्प्ड।
20 क्या है? 20 या अंडरडैम्प्ड।
हाँ,
ओके, वेरी गुड। सो दिस इज रेड से मैं कर लेता हूँ। नहीं, दिस इज अंडरडैम्प्ड। ओके, चलिए 400 वाला सेकंड। ना टाइम नहीं किया आपने अभी ये। दिस इज ऑल्सो अंडरडैम्प्ड। नेक्स्ट इज 900 वाला ओवरडैम्प्ड। को सॉल्व करना है आपको। नेक्स्ट इज 225 क्रिटिकली डैम्प्ड। नेक्स्ट तो लास्ट आ रहा है जिसमें ओमेगा 0 होगा, तो वो तो पता ही है आपको, दैट इज अनडैम्प्ड, जहां पे डैम्पिंग नहीं। I hope today we'll conclude this class, and tomorrow we have to start the derivations of this. Important classes will start tomorrow. ज़्यादा important, अभी तो भी important थे. Then we will be covering the gate. इसमें बहुत सारे gate के questions आते हैं. Please remember, we'll be covering all those questions what has been previously asked in the gate examinations. Okay.